Good morning, students. Good morning to one and all. In today's class, we are going to discuss. Good morning to one and all.
Good morning, ma'am.
Yeah. In today's class, I'll be going to explain the problems which we have dealt already, but some of them requested to explain it once again. So that I am explaining these problems once again. All of you listen to me carefully. I'll go in slow. Okay. Okay. These are see. Find the inductance per phase per kilometer of a double circuit line. He had asked you. What is he asked you? He has asked you to find the. In double circuit three phase line shown in figure 5, that is in the below slide, the conductors are transposed and are of radius 0.75 centimeters each. The phase sequence is ABC he had given you. Now he asked you to find the inductance per phase per kilometer length. Inductance per phase per kilometer length he had asked you to find. Okay. Now what is the GMR of a conductor? GMR of a conductor is nothing but the self GMD of that particular conductor. Here we are having the three conductors which are three phase double circuit lines we are having. So the diagram arrangement is as such. Here that is the conductor A, conductor B and conductor C. Each of radius how much? Each of radius 0.75 they had given you, right? Each of radius 0.75. Since it is a three phase double circuit line, this is the ABC phase and A dash, B dash, C dash will be the this is the arrangement for three phase double circuit line. Okay. Now here we are finding the GMR of the conductor. GMR of the conductor is nothing but 0.7788 into R. What is the radius he has given you? The radius has given as 0.75 centimeters. So that R into 0.7788. This we have derived in the last classes. What is GMR of the conductor? Sometimes it is called as the self GMD in case of inductances. Okay, that value gives you 0.589 value. See here in this figure, we have to find the distances between each and every of the conductor. See, in order to find the self GMD and mutual GMD, the self GMD formula is as such. It is for a conductor A, the self GMD for one first conductor is, it is of 4 root DAA, DAA dash and DA dash A dash and DA dash A. Okay, now this is the self GMD of the conductor A and this is the self GMD of the conductor A dash. Okay, now what is the formula for this? This formula is nothing but 0.7788 into R. Into R is that. Okay, what is R over here? R is nothing but 0.75, whatever we are having over here. This is the R which is nothing but 0.75. If you multiply this value, you will be getting as 0.589 centimeters. If this is changed to meters, now it is multiplied with 10 to the power of minus 2. So this value of DAA gives you the value, this one. Okay. Now DAA dash. See here, A dash value is, see this is the placement of conductor is here and we need to find the distances from here to here from this, right? A dash we need to find. What is the value of it? It is of value 7. A dash we are finding, it is 6 meters square plus 4 meters square it is. How we will see now? See, this is the A dash over here and now this is of length. What is that? 4 meters length. And what is the length of from here to here? It is of 6 meters, right? It is of 6 meters. How could you find the distance from A to A dash now? Root over 6 square, root over 6 square plus from Pythagoras theorem 6 square plus 4 square. What does it gives you? The value of under root gives you the value of 7.21. Now D A dash. What does this value? This value is again if the suffixes are same, that is the self GMR or nothing but the self GMD of the conductor, particular conductor itself. Here for the conductor A it is of 0.7788 into R. for conductor, distance from between the A dash for itself, A dash conductor itself, it is of 0.7788 into R. Okay, that value gives you again the same value as such, which is nothing but 0.584 into 10 to the power of minus 3 if it is converted into meters. Next one is A dash to A. A dash to A. What is the distance from A dash to A in this direction, right? This is also 6 square. This distance is 6. This distance is 4 meters. Under root 6 square plus 4 square gives you the value of this one 7.21 value. So obviously we will be getting the value as ds1 is equals to 0.205 meters. Okay. This is the self GMD of the conductor A. First one, that is for the conductor A. Now coming to the self GMD of the conductor B. Coming to this DBB is also for itself, the conductor B itself. What is the formula? 0.7788 into R. This is the formula. This is the formula again. 0.7788 into R. So you have kept the value as 0.584 into 10 to the power of minus 2 into DBB dash. All of you see here, what is the distance from DB to B dash? This is over here and this is like here. What is the distance of it? It is given as 5.5. What is the distance here given? 5.5. That only we had written over here there. Okay, this is the 5.5 meters, which is nothing but DB dash value is 5.5 meters here given. Okay, DB dash B dash is 0.584 into 10 to the power of minus 2, which is nothing but 0.7788 into R. This value gives you this value, this term. So this term gives the value of 0.584 into 10 to the power of minus 2 if it is converted in meters. Now again DB dash B's value is what? B dash to B, it is in reverse direction, is also the same as 5.5. So we have kept over here. Here we are having ds1 is this and ds2 is this. We shall see that ds3 is, here we have written ds1 is equals to ds3. We will see whether it is equal or not. ds3. Now what is ds3 value? Is equals to 4 root, is equals to 4 root dcc, what is that dcc value? DCC value is, see here, what is DCC? It is of 4 meters. What is it? DCC dash is equals to this one, right? From here to here. From here to here. What is the distance of it? Same as the above. This is the distance. You see, if you see this distance, this is 6 plus 6 square plus 4 square gives you the value of C to C dash. What is it? It's again the value same as that of the this one. CC value gives you, CC value gives you the self-inductance of this. This value is obviously equal to 0.7788 into R. That value is that, okay, 0.584 into 10 to the power of minus 2. C to C dash distance is what? C to C dash. Now it's coming to the next term, which is nothing but C to C dash D, C to C dash, C to C dash value, which is equal to what? Now it gives you the value of same as that 7.1. Why? Because C is here, C dash is here. The distance is from 6 square plus 4 square under root gives you the value of 7.1 here also. Okay. What is the next term we are having? D C dash C dash. What is the value? D C dash is nothing but the self. GMR of this conductor C dash itself. So C dash is over here. Itself means 0.778 into R. That value is 0.584 into 10 to the power of minus 2. So that value gives you this. And next one is, what is the next combination? D into C dash C. D into C dash C. D into C dash C. What is C dash C we are having? C dash is here and C is here. The distance we want to find 6 square plus 4 square under root gives you the value of What is that value? 7.21. So all the values here, DCC gives the same value of this and DCC dash gives you the value of 7.21. So D sub C dash gives you obviously this value, and this value DC dash C is also 7.21. If you simply substitute these values in place of this, you will be getting the same answer as 0.205. That's why I have written DS1 is equals to DS3. From the given diagram, by the placements of this conductor, it is the given diagram. The diagram is given in such a way so that from this given diagram, we have the values DS1 and after calculations, we got the values DS1 is equals to DS3. If the diagram is not like this, it is in somewhere different, then you have to find the distance in that according to the distances given in the diagram. So that you will be getting, you may get the different answer. But here you have got the DS1 is equals to DS3. Understood? Understood all of you? Hello, are you able to follow me now?
Yes, ma'am.
Yeah. DS is equals to, is it okay now? DS is equals to root over DS1 into DS2 into DS3. DS3 is nothing but the total equivalent self-GMD. Total equivalent self-GMD is this one. DS is equals to whatever we are having for the conductor A, that is this value 0.205. That is this value. That is this value. And whatever you are having for DS2 is 0.18. This value. Okay. Next one is nothing but the whatever DS3 is equal to DS1. So it is of 0.205. So this gives you the value of this one, which is nothing but 0.195 meters. 0.195 meters. This is how we need to find the self GMD for any particular diagram what we had given. Okay, well, for the data what they had given. This is according to the data. This is the given diagram for the problem, so that according to the given data we have found that DS1, DS2, DS3 we have got the value as 0.195 meters. Okay, next one coming to the, for every of the problem we need to find the self GMD and mutual GMD. Why? Because it is a formula 2 into 10 to the power of minus 7 log E dm by ds. In order to find the equivalent, in order to find the inductance. Okay, so our job is over in finding the self GMD. Now coming to the mutual GMD. Which is nothing but dm is equals to 3 root AB into DBC into DCA. What is the combinations of AB? DAB is equals to A to B. There is a, see here we are having A to B combinations. Okay, mutual between A to B. What is the distance? We are finding. See here A to B we are finding. This is the A to B distance. All of you listen to me carefully. Up to here it is of 4 meters, right? See, this is of up to here. This is of 4 meters. This length is 4 meters as parallel to this part. Okay. Now, this is the extra part whatever we are having now. This is the part we are having now from A to B dash. This we know from seeing this value. How we know? See, 5 minus 5.5 minus 4 gives you the value as 1.5, right? 1.5 we are having. Now, if this 1.5 is distributed equally to this side and equally to this side, 1.5 by 2, if you do, what it happens? It is equal to 0.75. What it is? It is of 0.75 we are having. See, this 0.75 is the distance from this point to B dash. This point to B, it is of 0.75. What is the distance of it? It is of 0.75. Here also the distance is 0.75. Okay. In order to find the distance of C dash to B dash and A to B dash, A to B, what is the distance of A to B now? See, this is the distance we have to calculate now. We know this distance and this distance. How can you find this one? 5 point. What is the distance of this? It is of 3 meters. 3 square plus 0.75. 0. It is of point, right? 75 whole square gives you the value of what is under root. It gives you value of 3.1. Under root gives you the value of 3.1. What is the value of this? This is of 3.1. This distance A to B is of distance 3.1. What is A to B dash distance? All of you listen to me. A to B dash is this. A to B dash is this. Okay. Now here we want to find the distance from, see we have found already here what is A to B dash distance, 3 square plus 4.75 whole square. How you got this value we will be going to see right now. 4.75. A to B dash is the distance of here from here. This is, what is this distance? It is of 3 value. Why? Because 3 meters over here. This is also 3 meters. This B is placed at a distance of this 4 plus 7.5. Again, this 4.75. From here to here, it is of 4 meters, right? This extra 7.5 meter length is there. So we are finding the distances from this to point here. We know that is the distance of this. So what is this? 4.75 is the total distance of this. So this is the total distance of from here to here. Let us suppose I'll rub it and draw it so that you can understand better. Yeah. See, this is all okay. Now see, this is the distance. What is this distance we want? A to B dash distance we need. A to B dash distance we need. Here is A and here is the B dash. That is at the extreme end we are having, right? At extreme end we are having. This distance is nothing but the 3 meters length, and this is at a distance of, see, this point is at a distance of not 4. It is 4.75. It is from up to here. What is the total distance? It is 4.75, and it is of this distance is nothing but 4 plus 0.75 we have to add. Why? Because this conductor B dash is at a distance of 5.5. This total length from B to B dash is 5.5. It is extra to that of 4 meters length, which is equal to the, this side it is of 0.75 extra. So 4 plus 0.75 will be having. So 4.75 whole square plus 3 square under root gives you the value of this one, 5.62. In the same way, A dash B. A dash B is nothing but here. A dash B is the, this is the distance. See, this is the distance. This distance is also 4.75 into plus root over 3 square under root gives you the value of 5.63. And the next one is A dash B dash. Where is A dash? A dash over here and B dash over here. What is this distance? This distance is obviously A dash B dash distance is what? A dash B dash distance is again. So in order to find this distance is nothing but the, we are having the combinations of A dash B dash as 3.1. So this is how you need to find the distances from. See, this is not at the, so A dash B dash is this side. This part we need to find. This is of, see here, this is 3 meters length and this is of 0.75, and so that you will be having under root 3 square plus 0.75 whole square, you will be getting the value of 3.1. This is not exactly parallel to this. This is somewhat distance away from the top, 0.75 meters. So we are having this line as this. So what is this value? 3 square plus 0.75 whole square gives you the value of 3.1 over here. Totally we will be having the value 4.17 meters. This is how you need to find the distance. See, for this point, particularly A to B dash, what is the distance? 3 square plus 0.75 whole square. That gives you the value 3 square plus here it is 3 square, and 0.75 whole square gives you the value of, again we are having the value of, what is this value? 3.1 we are having. Like this, 3 square plus 0.75, 3.1 we are having. That is the distance from D to AB. That is equal to 4.17. Similarly, from DCA value we have to find. Let us all erase this one so that you can understand better. So this is how you need to, this is the extra distance what we are having. So let us see all the, or arrange it like this so that it will be easy for you to understand. Okay. Yeah. Now coming to the next one, which is nothing but the DCA. What is DCA? CA. C to A. What is C to A distance? C is there here and A is there at the top. Okay. A is there at the top. So this distance is nothing but from here to here. It is of what? 6 meters length. It is of 6 meters length. Or 3 meters to 3 meters. It is of 6 meters length. Okay. Now DCA dash. CA dash means where? See here, A dash is here. This distance obviously had given you 4 meters length. So, okay, C dash A is again C dash A. It is again this distance 4 meters he had given you. That is you have written over here. D into C dash A dash. C dash A dash is again we have a distance of similar. This is the distance whatever you are having, that is 6 meters. 3 plus 3. That is the value you have written over here. So in the same how you need to find the distance from DAB, BC also the same. See, if you find the DBC, what is B to C? B to C, it is of distance C, B to C. This is the distance from B to C. Okay. B to C, B is over here and which is at a part of 0.75 from this part. So B to C again we are having 3.1. This is of 3 square plus 0.75 whole square gives you 3.1. In the similar way, we have B to C, B and C dash. B and C dash, where is it? B is over here and C dash is over here. What is this distance? It again 5.62. 5.62 we will be having. So again this is also D into C dash into B dash into C value also gives you this one, and B dash C dash value give you this 3.1 if you calculate. That is how you need to simplify this problem by seeing the diagram. This is the values what we have obtained. What is the value of this? DAB is equals to 4.17. DBC is nothing but also 4.17 and DCA is 4.9 we are having 4.9. This will give you 4.4 meters. Now our job is completed in finding the self GMD and mutual GMD up to now. Now you have to substitute these values in this formula. What is the formula of this? Inductance per phase per meter, which is nothing but 10 to the power of minus 7 log e dm by ds. What is dm? Mutual GMD. What is ds? Self GMD, which is nothing but, okay, this what value you have got for mutual GMD in this? See, mutual GMD is nothing but 4.4 you have got. What is the self GMD you have got? Self GMD is 0.195. You have to substitute those values 4.4 and 0.15 values in that, so that you will be getting this. This is Henry per meter. What is this? This is actually Henry per meter. Now, if you want to change it into the kilometers, what it happens? This 10 to the power of minus 7 is multiplied with 1000. This 10 to the power of minus 7 is multiplied with 1000. It becomes what? 10 to the power of minus 4, minus 4. 10 to the power of minus 4 into this value, which is nothing but 6.23 into 10 to the power of minus 4. It gives you value 6.23 Henry per kilometers. Henry per kilometers now. It is of value Henry per kilometers. Henry per kilometers now. Why? Because you have multiplied it with Henry per kilometer. Now, if further we want to change this one to Henry per millihenries, millihenry per kilometer, inductance per phase per kilometer in terms of millihenries means you have to terms of 10 to the power of minus 4 becomes what? This is 6.23. It will become 0. Why? Because one digit is reduced, so that it will become 10 to the power of minus 3. Instead of 6.23, you will be having the 0.623 into 10 cube, 10 to the power of minus 3, so that you will be getting 0.623 millihenries. What is the milli? 10 to the power of minus 3 you can written as millihenries. This is how you need to millihenry per kilometer. Actually, inductance per phase per kilometer in terms of millihenries we have got. That is nothing but 0.623. Likewise, you have to find the problems. Now understood all of you? Is it clear? Students?
Yes, ma'am.
Okay. Shall we go for the other problem?
Yes, ma'am.
Now, calculate the inductance per phase per meter for a three-phase double circuit line whose phase conductors have radius 5.3. He had given you 5.3 centimeters with the horizontal conductor arrangement as shown in the figure. This is the figure what we are having. This here also it is a three-phase double circuit lines. That is why ABC, A dash, B dash, C dash we have written line circuits whose phase conductors has a radius. That means each of the phase conductor, that is the conductor A, is having the radius of how much? It is of 5.3 centimeters. He had given you 5.3 centimeters. He had given you that each conductor is of radius 5.3 centimeters, and the distance between the conductor to conductor he had given as uniformly 8 meters. He had given. This is the given diagram. This is the diagram given by them. Okay, if at all the diagram is not given in the question, he had given you three phase double circuit lines which are equally distanced from each other with the 8 meters length distance apart from each other. If at all they had given you without giving this diagram, means you have to draw this diagram on your own. If here the diagram is given, so the distance from between each and every of the conductor is given as 8 meters. Uniformly they are given you as 8 meters length. So now let us find out the self GMD and mutual GMD for this in order to find the inductance calculations. Let us go for the all of you try to do in your notebook so that it will be easy to understand. GMR of the conductor is nothing but 0.7788 into R. What is the R he had given you? R he had given you as 5.3 centimeters. If you want to write this in meters, it will be 10 to the power of minus 2, which is equal to 0.0413 in meters. This is nothing but the GMR of the conductor. Each conductor, self GMD of the particular conductor for DAA, DAA dash, DBB, DCC, DB dash, B dash, DC dash, C dash. For every of the thing, the self GMD, self GMD, which is nothing but the GMR of the particular conductor itself, gives you the formula as 0.7788 into R, which is nothing but the radius, effective radius of the conductor. This is nothing but 0.7788 into R into the 5.3 into 10 to the power of minus 2, which gives you the value 0.0413 meters. Okay. Now, equivalent self GMD of first phase. That is the for one phase it is of equivalent GMD we are calculating. So for conductor A it is like this, and conductor B it is, and for conductor C. How we have found out this DS1, DS2, DS3 we will be seeing is how many parameters are there. The power is 1 by 3. If there are 4, so we will be having a DS4 whole to the power of 1 by 4. Here we are having the 3 conductors, so we are having DS1, DS2 and DS3. See here DS1. These are the combinations for this finding. So 0.7788 into R in 10 to the power of minus 2 gives you the value of 0.04. Here you have got this value in terms of meters. That value only I kept over here. What is DAA dash? DAA dash. Here we shall see the distance between A to A dash. See, here is the A, here is the A dash. What is the distance between them? 8 plus 8 plus 8, which gives you the value as 24. Which gives you the value as 24. So that's value I have kept over here. A dash is again the self GMD, which value is 0.0413. After substituting the values of R in 0.7788 into R, you will be getting the value of this one. So it is again D A dash A. A dash A. What is the distance from A dash to A? This is in reverse. Again, A dash to A, it is of 8. 8 plus 8 plus 8. That is again 24. So you have written 24 over here. DS2 is nothing but DBB. This is the combinations for the conductor B. This is the conductor B self distances, so that it is of 0.7788 into R. DB dash B is also the same. Now coming to the DB dash, B dash and B dash B. What is the distance from B to B dash? We will see. Let us see that B to B dash is this distance. That is again 8 plus 8 plus 8. So you will be having the distance like 24 here also. Here also you will be getting 24. Why? Because we are getting the same value for all the DS1, DS2, DS3. Why? Because they are placed at equidistance from each other. They are in symmetry. They are placed from equidistance from each other, so that we will be getting the same answer as DS1 is equals to DS2. If at all we see the answer for D, B dash B is also 24. Likewise, we have to see for the C and C dash C also. See, let us see. C is over here and C dash is also over here. We'll be having 8 plus 8 plus 8, which is nothing but the 24 value. If at all you find the C dash also, you will be getting the 24 value. Again, from in reverse direction also, the distance is same, that is of 24. So, finally, what is the conclusion? DS1 is equal to DS2 is equal to DS3. What is it? We have got the same values as DS1 is equals to DS1 is equals to DS2 is equal to DS3 value we have got. DS3, DS2 that is equal to and DS3 value which is equal to what? Which is the value which is equal to 0.995. So that is substituted in this formula, so that you will be getting this answer only. That 0.995 meters. Now self GMD of this equivalent GMD of equivalent self GMD we have calculated. Now we have to find the equivalent mutual GMD of the conductors. This is the formula for this. We have to see the distances. Now the distances are different. A to B is different. A to B dash, it is 32. How we will see? A to B dash. A is here and B dash is here, right? B dash is here. What is it? 8 plus 8 plus 8 plus 8. 8 fours are 32 value you have got. See, A to B dash, it is a mutual combination between from A to B. So that combinations from A to B, it is of 8 meters. A to B dash, it is of 32. B dash to 8, it is of, see, B dash to 8 is how much? Any one of you, can you tell what is the distance from B dash to B? B dash to B. Hello? B dash to B, what is the distance? 8 plus 8 plus 8. Well, how much it is?
24.
24.
24.
Yeah, 24 is the distance. So, B dash to B is B dash to B. Wherever we are having B dash to B, it is of 24. Now we are having A dash B. What is the distance from A dash to B? A dash to B is how much? 8 plus 8, which is of 16. 16 value. That value you have kept over here. Similarly, you have to see for the A dash B dash. That is the 8. In this way, you have to find the distances, so that you will be getting the answer 13.45. In the similar way for DCA and similar way for DBC also. If you substitute these values in this, you will be getting the value of 14.518 meters. Now, inductance per phase per meter. Here the units are very, very important. Inductance per phase per meter, if at all given, the into 10 to the power of minus 7 you will be getting. In kilometers means into 1000. After doing into 1000, what it happens? It becomes 10 to the power of minus 4. If you want to change it into millihenries, again, whatever may be the answer into 10 to the power of minus 4, if suppose 5.36 into 10 to the power of minus 7 you have got, I mean minus 4 you have got, this is multiplied with 1000, what it happens? What it happens? It is of 5.36 into 10 to the power of minus 4 into 10 to the power of minus 4 it is. See, it is of minus 4 if it is per kilometer length. If it is for kilometer, if you want to change it to the millihenries, what it happens? If this is multiplied with 5. See here 0 536 into 10 to the power of minus 3. 10 to the power of minus 3, which is nothing but millihenry per kilometer. What is it? Millihenry per kilometer. Millihenry. 10 to the power of 3, if at all you put, you need not put milli. If at all you don't put 10 to the power of minus 3, it will be millihenry per 0.536 millihenry per kilometer. You have to write per kilometer, the units. It will they'll be confusing you whenever they are giving in any bits, so that you should be aware of what is the value of it for exactly. If this value is not there, it is having now 0.536 millihenry per kilometer. That means milli is nothing but 10 to the power of minus 3. Okay, 0.536 millihenries. Likewise, you have to find the problems. This is very, very important. I hope you all understood. Is it clear? Is it clear now?
Yes, ma'am.
In a single phase line, figure 7, conductor A dash in parallel from one conductor, while conductor B to B dash in parallel form the written path. See here, the question is given in such a way that if the conductor A and A dash is in this fashion and B dash and B is in the B dash B is in the written path of it. Why it is written path? For any of the conductor, in order to flow the current requires the closed path, so that it is acts as the written path for that he had given you. The parallel forms the written path, calculates the total inductance of the line per kilometer, assuming that current is equally shared by the two parallel conductors. Conductor diameter is 2.0 centimeters he had given you. See, in the question itself, what he asked to find? Total loop of the, see, he had asked you to find in a single phase line, figure below, conductor A and A dash is parallel to that of the other conductor B and B dash. In parallel forms the written path, which forms the written path. Calculate the total inductance of the line per kilometer, assuming that the current is equally shared by the two parallel conductors. Conductor diameter is 2.0 centimeters. What does it mean? See here, he had asked you to find one is acts as the written path to the other, means you have to find the loop inductance. Loop inductance. So we need to find the loop inductance over here. What is the formula for loop inductance? Loop inductance, it is of 2 into 10 to the power of minus 7 log e 10 to the power. See here, 2 into 10 to the power of minus 7 log e dm by ds. For this formula, whatever we are having into 2 you have to do. See, 2 into 10 to the power of minus 7 into 2. See, 10 to the power of minus 7 into 2 log e dE by log e dm by dE. What is dm? Mutual GMD. What is dm? Mutual GMD. What is ds? Self GMD. What is the value here? This 2 into 2 becomes what? 2 into 2, 4 into 10 to the power of minus 7 log e dm by ds. If it is per kilometer, meter length. See here he had given you the value as kilometer. So 4 into 10 to the power of, actually it is of 4 into 10 to the power of minus 7. See, this is 1 minus 7 log e dm log e dm by ds. dm by ds we are having. So this is changed to, this is in meters if suppose. Now he had given you in kilometers. So here it is for Henry per meter it is. What it is? It is of Henry per meter. Henry per meter. All of you listen to me carefully. It is of Henry per meter. Here it is of kilometers. Means we have to multiply this term with 1000. You have to multiply this term with 1000, so that you will be having the value as 10 to the power of minus 4. That's what he had given you straight away. Tell L is equals to 4 into 10 to the power of minus 4 log e dm by ds. That's why the loop inductance formula is written Henry per kilometer. Units are very, very important. Per kilometer. For this, you have to find the terms of what is dm and ds. Okay. This is same as the above. The procedure is same. DAB, it is of D to A. AB is how much? 20 plus 100, it is of 120. A to B dash, what is it? A to B dash. B dash is here, A is here. 20 plus 100 plus 20, it is of 140. A dash B, A dash B, it is of 100. A dash B dash, it is of 100 plus 20, it is of 120. Same way for all the things, A to B, B to C and C to A, if you find the distance of it, I mean, you will be getting the values as such. DS1 is equals to, this is the mutual GMD finding. So A to B, here you are having only two conductors. So A to B and B to A you will be having. So mutual GMD is only one value. Why? Because AB, A B dash, A dash B and A dash B dash. We have all the combinations over here. This is only the one value we are getting. That is the mutual value, which is nothing but 119 centimeters. Now coming to the self GMD. Self GMD of the conductor. Two terms you will be getting for self GMD of A, DS1 and DS2 you will be getting. See here, DS1 is again what we are having. DS is equals to DAA, DBB. DAA means what? A to A, it is 0.7788 into R. What is R? R is 1 over here. 1 D by 2, right? Diameter is given as 2.0 centimeters. Radius it is 2.0 by 1. It is of 1 meter centimeter. Now you will be having as 0.7788 into 1. Actually, the R is 1 over here. R is equals to 1 over here. You will be having the value of 0.7788 centimeters itself. Similarly, A to A dash and all that we were having. Now, see the difference. DS is equals to we will be having 2 root DS1 DS2. What is DS2? DS2 for the B combinations. DS1 and DS2 we are having. DS1 and DS2 we have. What is DS1? For A conductor and DS2 for B conductor. See here, in place of this, if you place 4 root, again we have to find DBB also over here. See here, DBB, DBB in the same way into DB dash, DB dash, B dash, DB dash A. What is BB? B to B it is self, 0.778 into 1. It is equal to 0.7788. And DBB dash is what? B to B dash's distance is 20. 20 you will be getting. Okay. And again B dash is 0.7788 into R. B dash to B is again 20. You will be getting the same value. So DS1 is equal to DS2. DS1 is equal to DS2 you will be having. So after some simplification, you will be having the values like this only. DS1 it is actually, DS1 is value is this. DS2 value is also same as this value. So that DS is equals to 2 root. So what it is? Finally 3 point, sorry, I'll wrap it. Is of 3.17 into 994. It is 3.94 whole to the power of 1 by 2. You can write like this. Whole power 1 by 2. You will be having the same answer as under root. I mean, this is the under root becomes 1 by 2. I mean, you will be having the value. This is DS1 value. DS2 is also the same values. 2 root DS1, DS2 value gives you the value of this one. Finally, you will be having the value of this. And finally, see, L is equals to 4 into 10 to the power of minus 9. Self GMD and mutual GMD, you will be having the values as 3.94 and 119 by 3.94. You will be having this value in terms of Henry per kilometer. Henry per kilometer we have written. This is milli Henry per kilometer. Likewise, you have to find the problems. Understood all of you? These are the models what we have come across in inductance formula, calculations. Now coming to the bundle conductors. What do you mean by the bundle conductors? See here, these are the bundle conductors. What are these? See here, more conductors are grouped together like this. This is the bundle conductor for the single circuit transmission line. See, you can see clearly it is double circuit transmission line A, B, C, A dash, B dash, C dash. Here these are the bundle conductors. Here these are the bundle conductors. That means three conductors are bundled together. Three conductors are bundled together. You can see clearly this. Here there are four bundle conductors are there. How many conductors are there? Four bundle conductors are there grouped together. These are the subconductors in that bundle conductor. This is the spacing between the conductors. Where we use this bundle conductors? Bundle conductors made up of two or more subconductors, or called, if the conductors are having two or more subconductors, are called as bundle conductors. Bundle conductors are used in the transmission line if the voltage exceeds 230 kV. If the voltage exceeds 230 kV, in order to eliminate this corona losses and radio interference in the transmission line, in order to improve its efficiency, transmission line efficiency, we have been used these bundle conductors. If bundle conductors are used, what happens? Its radius of the overall effective radius of the conductor would be increased. See, instead of this, the radius of this is somewhat, suppose it is a 0.5. If the conductors are grouped together, the radius of this would be increased, so that what happens? If the radius is increased, effective radius of the self GMD increased, the inductance L decreases. What happens? L decreases. If L decreases, what happens? If X is the self GMD is increased, if R is increased, what happens? The L will decrease. This will leads to the XL. What is it? Inductive reactance. Inductive reactance. Omega L would also decreases. Omega L would also decreases. If this omega L decreases, you will come across the steady state stability limit in the later on subject. Okay, steady state stability limit we can say that is equals to P max is equals to EV by X. If X decreases, what is the formula? P max is equals to P max is equals to P maximum is equals to EV by X. EV, this is EV by X. If X gets reduced, what happens? If X gets reduced, P max will get increased. P max will get increased. If P max gets increased, the real power will be maximum. That would improve the steady state stability limit. This is also one of the important. So if L decreases, XL also decreases, then voltage drops. What is that? Voltage drops is also will be decreased. So voltage regulation will be improved. What is voltage regulation? Voltage under no load minus full load by full load, that gives to the voltage drop. This all leads to the efficiency of the transmission line, and also you are having the character impedance of the transmission line would also decreased. Surge impedance loading is also increased. What is this? We will be going to see in the next chapters, that is on long transmission lines. We will be going to see what is the character impedance and what is surge impedance loading, and all that you will be going to see. Okay, if at all the conductor diameter has been increased at such high voltages, ordinary conductor, what does it do? It leads to the corona loss. This will reduces the transmission efficiency, and if the corona is increased, what will happen? Power losses will be more. So the bundle conductors with 3 or 4 conductors have been in each of the phase. In each phase, 3 or 4 conductors are bundled together. This is for one phase only. See, if you see the previous diagram, for one phase, 3 or more conductors are bundled together like this. If it is done like this, what it happens? The effective radius of the self GMD will increase, and self GMD leads to the steady state will increase as inductive reactance will decrease. If inductance is decreased, inductive reactance would decrease. This would lead to increase in the self steady state stability limit, which is nothing but the Pmax value, and thereby the power factor will also improved in the transmission line, and thereby the voltage drops is also gets reduced, so that the profile, the transmission line efficiency will be increased. That is why we will be using that instead of single conductors, we have been using the bundle conductors. That is why in every of the problem we have come across the double circuit three phase line, single circuit lines. We have single phase double circuit line. We have talked like that. What does it mean? In the three phases, each phase comprises of four conductors. Subconductors are placed like this. Let us suppose here we have taken the four conductors. That bundle, that is called as a bundle. Four bundle conductors we have space. This is the spacing of this. If it is done like this, what does it happens? If this resistance has been increases and the conductor size has been increases, this whenever we are having the voltages exceeds the 230 kV, and that time we will be using these bundle conductors in the transmission line in order to eliminate this corona loss and communication effects in the communication lines and significant power losses and thereby improving the power transmission efficiency, transmission line efficiency, and reduces the voltage regulations. These are all the benefits. These are all the improves the steady state stability limit. Surge impedance loading has been decreased. The surge impedance loading has been increased, and character impedance has been decreased. Let's see what are those two terms we'll be going to see in the next chapter. My next chapters in long transmission lines. Okay, so up to now you'll be aware of what is. You know that transmission efficiency has been increased by using this. Steady state stability limit has been increased, and the reactance has been decreased. If at all it decreases, the power factor will also increases. Thereby, the efficiency of the transmission line would be increased. That is why we go for the bundle conductors. Now, these are all the advantages of it. Bundle conductors are primarily employed to reduce the corona loss and radio interference. That was the thing we have discussed right now. So in case of the single conductors, this effect would be more. If at all they are used as a bundle conductors, this effect is less, and so that it improve radio interference also will be read. If the voltage exceeds some critical disruptive voltage, then this corona will come into existence in the transmission line. This will leads to the hissing noise and radio interference around that of the line, so that the efficiency will get reduced. By using these bundle conductors, you can reduce that. How to reduce? Actually, we'll be going to say in this concept, which is nothing but the corona concept. We'll be come across in the 6th unit most probably, that the concept in that also you'll be come across this how to reduce these losses by using the bundle conductors. Okay, improvement in the transmission efficiency as due to low corona effect, bundle conductor lines have higher capacitances to neutral in comparison with single lines. So this would improve the power power factor, higher power factor. If the capacitance is increased, the power factor is also improved. These are all the advantages of by using the bundle conductors. Bundle conductor lines will have higher capacitances and lower inductance than ordinary lines they will have. This is the main advantages. These are all the main advantages by using the bundle conductors. That is why for voltage exceeds when greater than 230 kV, we will be going for the bundle conductors. In the next class, we will be going to discuss about what is electric potential, what is the how to find the capacitances in the transmission line, and all that we will be going to see in the next class. Thank you. If at all anyone is having any doubt, you can ask me right now. This is about today's class discussion. If anyone is having any doubt,